In this project, we will provide a summary of the major steps in our product development process. Team 1. Following the methodology of PDP, where the first step is identifying opportunities, creating a successful product begins with the understanding customer needs and delivering solutions at a low cost. And here's where brainstorming becomes essential. This structured method helps us to generate a pool ideas where the team members generate ideas from its own perspectives. From our brainstorming sessions, we identify promising concepts. Each of these ideas represents a starting point for creating real customer value. After generating a wide range of innovative ideas, the next step was to prioritize them using a structured decision-making approach. For this, we applied the analytic hierarchy process, which allowed us to evaluate each concept against key criteria. The criteria we considered were introducing something new to the market, offering a significant improvement with unique value, big market potential, promoting sustainability, easy of prototyping. The opportunity selected through this process is safety traffic barrier, a solution that improves the logistics and deployment in the field. The problem statement its purpose is to define the scope of the project. Of initial analysis revealed a critical challenges. Road safety barriers had a bulky design that creates major logistical problems. High transportation costs due to the low density, warehouse saturation, difficult in time, and consuming installation. Our team after developing a clear problem definition apply AI tools to refine it. Our goal is to transform these limitations into opportunity by designing a solution that optimizes storage, reduces transportation costs, and enables quick deployment. For our project, the challenge is the current road safety barriers are bulky, difficult to store, expensive to transport, and complex to deploy. These limitations result in a high logistics cost and operational inefficiencies. The mission statement defines the scope of this development effort and sets the direction for our team by outlining the objectives, designing a road safety barrier that optimizes storage, maximizes shipping capacity, and simplifies deployment. To consolidate the needs, our team met to compare perceptions, identifying key stakeholders, and capture as many requirements as possible. Each team member first creates an independent list of needs, and then we combine them into a single comprehensive list. Next, we prepare an interview template to guide our conversation with stakeholders. We conduct interview in 3 stages with colleagues, AI, stakeholders. The information gathered was processed using AI tools across 5 critical interpretations of needs. To better understand satisfaction, we apply the Kano methodology, which classifies needs into 3 categories: basic requirements, must-have conditions such as regulatory compliance, nighttime visibility, and resistance to UV and heat. Performance requirements, features that drive functional satisfaction, including volume optimization, freight cost reduction, and waste minimization. Delight requirements, unexpected features like payment-friendly anchoring. Our next step as a team was to turn that list of requirements into something measurable. We wanted to eliminate the subjectivity behind words like easy or fast, so we assigned specific units of measurements. For example, for heat-resistant base, we defined the exact temperature range in degrees Celsius that product must withstand. To establish these metrics, we rely on current Mexican standards, which the product must be to be marketed. These standards include standardized tests that guarantee the product performs in the specific functions. We capture this in a section called Regulatory and Acquisition Restrictions. Using the black box tool, we apply functional decomposition based on the sequence of the user's actions. This design approach breaks the safety barrier system into smaller, manageable functions organized by the chronological order of the real-world interactions during deployment and operation. Unlike traditional methods that group functions by technical subsystem, this approach focuses on what the user actually does: storage, transportation, and positioning. In the external search, we located existing solutions through 4 steps. Consulted experts. We had the opportunity to interview professionals with experience, and we were able to closely understand their needs and experience related to the use of safety road protection barriers. Patent search. The patent search and analysis makes possible to identify both relevant prior art and innovation gaps in the field of modular road barriers. Published literature. The literature review was focused on researching the standards and guidelines applicable to the roadway protection barriers. Benchmarking. The benchmarking analysis demonstrates that the proposed concept is comprehensive, particularly in areas such as transport, volume optimization, ease of installation, and structural stability. The concept generation phase following the internal search stood out for its innovative application of bioassociation, biomimicry, and trees theory. Bioassociation, the team applied bioassociation by selecting stimuli from everyday object toys and natural forms, then mapping their functional principles to various requirements such as modularity, compactness, and stability. Biomimicry, the team analyzed biological systems that exhibit properties such as adaptability, energy absorption, anchoring, and visibility. Trees was applied to other conflicts such as stability versus portability, durability versus weight, and visibility versus complexity. For the start of concept selection, the concepts that were generated, each member carried out a multi-vote to obtain the promising 20 concepts. Then was performed a concept screening to narrow the 9 best concepts. Using the screening concepts, the team began the HHP process presenting the key characteristics essential for the design of our final concept. The AHP outcome, the accordion hermetic sealing base plate. This system separates the product into a lightweight main body and a heavy base that provides stability. The base connects to the body through a secure interlocking mechanism inspired by Tupperware containers, ensuring quick assembly without tools. The main body features an accordion-like collapsible design for compact transport and quickly deployment, incorporating photoluminescent pigments and red reflecting ensures maximum visibility in all night conditions. This project was more than design and safety barrier. It was about applying a structured, innovative process. We began identifying opportunities, defining the problem, and prioritizing customer needs using tools like HHP and Kano. Through external and internal searches, we explored patents, standards, and creative methods such as association, biomimicry, and trees theory. Finally, concept selection combined data-driven analysis with creativity. The result, a solution that optimizes logistics, improves safety, and proves that innovation often comes from adapting existing ideas to new contexts for better results. Few concepts will be entirely disruptive, but incremental innovation can create real impact.